Okay, so let's take the next example here. F of x equals to x plus 2 over x minus 1. So we are asked to find the vertical asymptote. So what we do, we have this denominator, we set denominator equals to 0. So we have x square minus 1 equals to 0. Okay, now this is a quadratic equation, right? Now let's solve this. So we need to factorize this, or what we can do is that we can use the square root principle. So let's add 1 on a both side. So we have x square equals to positive 1. Now how do we get rid of square? We get the square root on the other side. So we have x, and do not forget plus or minus square root of 1. Okay, so we get plus or minus 1. So let's take plus 1. So x equals to 1, x equals to negative 1. And these two are the vertical asymptote. So when we take positive 1 or negative 1 for x, our denominator is 0. So x is equals to 1 and x equals to negative 1 are the vertical asymptote. So these are the vertical asymptote. So you find a number that make denominator equals to 0 and write x equals to that number. Okay, you are not required to show all these. Okay, you can do this on your head as well. But make sure you have to have x equals to a number that make denominator equals to 0. That is the vertical asymptote. Okay, now similarly for number C, we have this function. So we are asked to find the vertical asymptote. So you set your denominator equals to 0. So we have 2x plus 1 equals to 0. Let's solve this equation. So we subtract 1 on both sides. So we have 2x equals to negative 1. Now to get rid of 2, we divide both sides by 2. And our x is negative 1/2. And this is the vertical asymptote. You set your denominator equals to 0, or you can find negative 1/2 without solving also. So vertical asymptote is easy. Okay, so you find a number that makes the denominator equals to 0 and make sure you write down x equals to that number. Okay, these are the vertical asymptote. And once we know the vertical asymptote, what can we say about the domain? Like our vertical asymptote is x equals to negative 1. Now what can we say about the negative 1 for the first function? Is that negative 1 a domain or not? No, right? Vertical asymptote is exactly at the point where the function is undefined. So negative 1 is not a domain for f of x. Okay, similarly negative 1 is not a domain for second function. And similarly negative 1/2 is not a domain for the third function. Okay, so if you have a graph and if you see the function is undefined at some x values, then those x values. So at those x values, we have the vertical asymptote. Okay, like here. So here, so the function is undefined at 1. So we draw vertical line at 1. And this vertical line is the vertical asymptote. So here, this vertical line is vertical asymptote. Okay. Okay, the next we have horizontal asymptote. Okay, so let me draw here. So let me take the same graph that we had earlier. So we have the vertical asymptote at 1. So this is 1. Okay, and when you draw a graph, your function is undefined at 1. So it goes all the way down. It never touches. Okay. So this is the function that we had in the very beginning. Now, as we take our x, very big number, it means as our x approaches to positive infinity. So our f of x is 1 over x minus 1. Now, as we take our x to be a very large number, let's take x equals to like 1000. So we have 1 divided by 999, right? And what is that number equals to? So what is 1 divided 999? That is close to 0, right? It's not 0. Okay, see, like when we take our number like 1000 here, we get our output very close to 0. It means it's not equals to 0, but it is very close to 0. Okay, our f of x is very close to 0. Similarly, if we choose a number which is very less, which is very small, it means if our input is very small, like negative 1000, now what will be our output? It means if we go all the way to the left, okay, this graph is very close to this x-axis, but it never touches x-axis. Okay, the output is very close to 0, but it is not equals to 0. Our f of x is close to 0. So we have a very big number, we take very big number, we take very small number, and in that case, if our output is very close to some number, so in this case it is very close to 0, then in that case y equals to, like, whatever number you have equals to 0 is the horizontal asymptote. So in this case, our x-axis, which is y equals to 0, is the horizontal asymptote. Okay, so for the horizontal asymptote, we take our input to be very large, we take our input to be very small. Okay, and in that case, if our output is very close to some number, it's not always 0. Okay, so it can be any number. Like for example, so I can add one more graph here. Let's say this is 3, and I have a graph that looks like this. Now as I go all the way to the negative infinity, this, our output is very close to this line, which is 3. Okay, so here, as our x is very small number, our f of x is close to 3. So y equals to 3 is the horizontal asymptote. So this horizontal line is the horizontal asymptote. You choose your input to be small or big. And when you choose your input to be small or big, if your output is close to some number, then y equals to that number is the horizontal asymptote. Horizontal asymptote is a horizontal line, and line has to be an equation, so we need to write y equals to that number. Okay, this is a number where your output is close to, when you choose your input to be large or small. Okay, and vertical asymptote is like you choose a number, and if when you choose a number when your input is close to some number, if your output is very big or output is very small, then x equals to that number is the vertical asymptote. And in the horizontal, for the horizontal asymptote, we find a number. Okay, we choose our input to be large or to be small, and if our function or if our output is close to some number, then that output equals to y is our horizontal asymptote. Okay, so like if we compare these two things here, so we have vertical asymptote, we have horizontal asymptote, right? The very first difference is that vertical asymptote is a vertical line, right? The horizontal asymptote is a horizontal line. That's the very first difference. Okay, now for vertical asymptote, you choose a number. Okay, so for x equals to some number, let me call a. Okay, if your output f of x is a very big number, or f of x is very small number, then x equals to a is vertical asymptote. Okay, vertical asymptote is a vertical line. That's the very first thing that we need to know. Okay, and for x equals to some number, we don't know what number is that. If your output is very large or very small, then our x equals to a is a vertical asymptote, like the one that we had. Like let me just rewrite. So f of x equals to 1 over x minus 1. When we choose x equals to 1, what happens? We have 1 divided by 0, and that is infinity, right? So our output is infinity. That's undefined. And if that is the case, x equals to 1 is the vertical asymptote. Now for the horizontal asymptote, okay, if your input, x is the input, if you choose your input to be very large, or if you choose your input to be very small, okay, just let me, if, then f of x, it approaches to some number, let me call b. Okay, then y equals to this number, b is horizontal asymptote. So for the horizontal asymptote, you choose a very big input or a very small input, and if your output approaches to some number, okay, your output is f of x, it should not be, it won't be equals to 0, okay, it is very close to that number, like here, so as we choose very small number, this graph, it approaches very close to 3, but it is never equals to 3. So y equals to 3 is the horizontal asymptote. Okay, now there is a method of finding the horizontal asymptote, and for that we need to know the degree of numerator and degree of denominator. And how do we find the degree of a function or a degree of a polynomial? Find degree is the largest exponent, right? So let's do that. So here, so we have this p of x numerator, q of x denominator, and let's take n as a degree of a numerator. Okay, so we have n as a degree of numerator and we have m as a degree of denominator. If the degree of numerator is less than degree of denominator, okay, we have a function and the degree of numerator is less than degree of denominator, like the, for example, so here example 1, so what is the degree of numerator here? Can you tell me the degree of numerator? 1. And what is the degree of the denominator? 2, right? So in this case our numerator degree is less than denominator degree. If this is the case, then our horizontal asymptote is always y equals to 0. So horizontal asymptote, let me just write, horizontal asymptote is always equals to 0. And this is when the degree of numerator is less than degree of denominator. So you have a function, it doesn't matter what kind of function you have. You check the degree, you find the degree of numerator, you find the degree of denominator, and if the degree of numerator is less than degree of denominator, then y equals to 0 is always horizontal asymptote, like the one that we had very first time. So just let me add one more example. So if our f of x equals to 1 over x minus 1, so our numerator is 1, this is a constant number. What is this degree? So if we have a constant number or a constant function, the degree is always equals to 0. And the reason is that we can write 1 as a 1 time x to the power 0. Do you all agree? X to the power 0 is 1 and 1 time 1 is 1. So the degree of numerator is 1 here and the degree of denominator is, the degree of numerator is 0 here, I'm sorry, because the exponent is 0. What is the degree of denominator? It's a 1, right? So our degree of numerator is less than degree of denominator. And if this is the case, your horizontal asymptote is always y equals to 0. And that's what we had in our graph here, see? So this graph, so this is y equals to, x-axis is y equals to 0. This is the horizontal asymptote. So if the degree is less than degree of, if the degree of numerator is less than degree of denominator, every time, okay, not only in this example, every time y equals to 0 is the horizontal asymptote. Okay, the next condition, what happens if the degree of numerator is equals to degree of denominator? Now we might have a function where the numerator degree and denominator degree is equals to each other, like in the second example. What is the degree of numerator here? 1, right? What is the degree of denominator here? 1. So we have same degree in the numerator and denominator. And if this is the case, then our horizontal asymptote y is equals to coefficient of leading term in the numerator. Okay, just let me write down a. A is the coefficient of leading term. Okay, so a is the coefficient of leading term in numerator. So we have, okay, a, y equals to a divided by b, and b is the coefficient of leading term in the denominator. So b is coefficient of leading term in denominator. So this is our horizontal asymptote, y equals to a over b. A is the coefficient of leading term in the numerator and b is the coefficient of leading term in the denominator. Now here, what does it mean by leading term? Leading term is a term with the highest exponent. Okay, so let me write this function b. So we have f of x equals to 2x plus x plus 1. Now in the numerator, what is the degree? What is the term here with the highest degree in the numerator? We only have one term, right? So what is this coefficient? 2. So this is the leading term. So our horizontal asymptote is y equals to 2 divided by, in the denominator, which term is the leading term? X or 1? Okay, x has a degree 1, 1 has a degree 0, and the term with the highest degree is the leading term, and its coefficient is 1. So 2 over 1, which is y equals to 0, is the horizontal asymptote. So if we have a degree same in the numerator and denominator, okay, then the horizontal asymptote is a divided by b. A is the coefficient of leading term in the numerator divided by coefficient of leading term in the denominator. Okay, so let me add one more example. So if we have f of x equals to 4x cubed negative 2x squared plus 9 divided by 2x cubed minus 1. Now this is the function here. What is the degree in the numerator? 3. Okay, 3 is the degree because this is the highest exponent, and in the denominator our degree is 3, right? We have the equal degree in the numerator and denominator. In this case, horizontal asymptote is y equals to leading coefficient of leading term. Now in the numerator, which one is leading term? We have 3 terms, 1 2 3. Which one is the leading term? 4x cube is the leading term. So 4 is the coefficient. 4 divided by, in the denominator, leading term is 2x cube and its coefficient is 2. So y equals to 2 is the horizontal asymptote. Okay, you divide the leading term of the numerator coefficient, okay, only the coefficient. You divide the coefficient of leading term in the numerator by the coefficient of leading term in the denominator equals to y. That is the horizontal asymptote. Okay, and the last case here, if the degree of numerator is greater than degree of denominator, then in that case there is no horizontal asymptote, like in number C. So in number C, what is the degree of numerator here? 2. What is the degree of denominator here? 1. So our case is the degree of numerator is greater than degree of denominator. In this case, no horizontal asymptote. Okay, so if your degree of numerator is greater than degree of denominator, then there is no horizontal asymptote. Okay, all right, so let's do this much for today. The remaining we'll do in our next class.